We continue our lesson on arithmetic progression. This time we will have a look on the sum of an arithmetic progression. Suppose we have to find the sum of this sequence. We have to find the sum of the first 30 terms of the sequence. As you can see, it is an arithmetic progression where the first term is a and the common difference is 2. So one way to do this, we can add 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. We go on like that until we reach the 30th term. So we add all these 30 numbers together, we will obtain the sum of the first 30 terms. It's easy because we have only 30 terms. But what will happen if we have to find the sum of, say, the first 100 terms? Again, it is possible, but what about the time it will take? So, instead of doing this, fortunately we have two formulas which enable us to calculate the sum in a very easy and less cumbersome way. So, these two formulas are, so first of all, let's proceed with the notation. So the notation. Here we have Sn, which denotes the sum of the first n terms. You will see that we talk about the first n terms. So if we say S10, this means the sum of the first 10 terms in the sequence. We have to take the first 10 terms. This is S10, and not from the 11th to the 20th term. This is not the first 10 terms. This is found in the middle or at the end. So these two formula that I will give you, it applies only for the sum of the first n terms. So S50 denotes the sum of the first 50 terms. So let's see these two formulas. So the sum of the first n terms of an AP can be written as, so we have two formula. The first one is Sn is equal to n over 2 into A plus L. If you remember, A is the first term and L is the last term of the sequence. So to use this formula, we need to know the last term of the sequence. And the second formula is Sn is equal to n over 2 into 2a plus n minus 1 times d. So here we need the first term and the common difference. So depending on the information given, you have to choose which formula to use. It is also useful to remember this rule. The nth term can be obtained by taking the sum of the first n terms, that is Sn, minus the sum of the first n minus 1 terms. So this is very useful. Let's see a first example. Find the sum of the first 30 terms of the sequence 1, 3, 5. So here we don't know the last term, that is the 30th term. This we don't know. So we will use the second formula. So here we have to find sum of first 30 terms, that is S30. So we apply the second formula. We obtain 30 over 2. Here 2 times A. So A is 1 and D is 2. So it's 2 times A plus n minus 1. Here n is 30. n minus 1 becomes 29 times D, which is 2. So we have 58 plus 2 is 60. And then 60 times 15, we get 900. So we know the sum of the first 30 terms is 900. Very easy. Now, if we want to use the other formula, that is n over 2 into a plus l, we have to find the last term. The last term is the 30th term. So we can find this term, that is u30. And u30 is a plus 29d. We obtain 1 plus 29 times 2. 58 plus 1 is 59. So now we know the last term of the sequence. So we use the other formula, S30. It's 30 over 2 into A, that is the first term plus the last term. So again, we obtain same answer, 900. We have a second example. Find the sum of all the terms in the sequence 5, 10, 15, 20, 25 up to 300. So clearly it is an arithmetic progression where the first term is 5, the common difference also is 5, and here we know the last term, it is 300. But the problem is that we don't know how many terms there are from 5 to 300. So here the number of terms n itself is unknown. So to be able to find the sum of these terms, we need to know how many terms there are first. So if we are able to know which term represent 300, we will be able to know how many terms there are in the sequence. So we let the nth term be 300. Here we use the formula for the nth term, the formula we use in lesson 1. So un is equal to a plus n minus 1 times d. So here un, the nth term, is 300, 5 plus 29 times d. Here we have sorry, made a mistake here. So un is equal to 5 plus n minus 1. So n is unknown. We have to find n. And then we have 5. So we have 5n minus 5. Then we have 5n, which is equal to 300. N is equal to 60. So this is the 60th term. Therefore, we know that we have 60 terms from 5 to 300. So n is equal to 60. Now we can find the sum of the first 60 terms. So S60, here we can use the formula where we have the last term. So we have 60 over 2 divided by A plus L. So we have 30 times 305, which is 9,150. So here, first of all, we have to find the number of terms. So we let un is equal to 300, and then we obtain n as 60. We know that there are 60 terms in the sequence, and we apply the formula, the first one, where we can use the last term. Now a third example. The 10th term of an AP is 14, and the sum of the first 7 terms is 42. Find the first term of the progression and the common difference. So here we are given the 10th term, that is U10 is equal to 14. So we use a formula for the 10th term, which is A plus 9D, which is equal to 14. So we don't know the first term and the common difference. We write them as A and D respectively. So this is equation 1. And then we are given that the sum of the first 7 terms is 42. So the sum of first 7 terms, which we write as S7, is equal to 42. So here obviously we don't know the last term, so we apply the second formula. S7 is 7 over 2 into 2a plus n minus 1. So here n is 7, n minus 1, it becomes 6 times d, and this is equal to 42. We can write it as, so we have 14a plus 42d is equal to 84. And then we can divide by 6. We can divide this equation by 6. We obtain, by 14. So we obtain a plus 3d is equal to 6. So this is a second equation, which is in terms of a and d. So we can solve these two equations simultaneously to obtain a and d. So we take 1 minus 2. We obtain 6d is equal to 8. Therefore, d is equal to 4 over 3. Now we substitute d by 4 over 3 in equation 1. We will obtain a plus 9d is equal to 14. A plus 9 times 4 over 3 is equal to 14. So a plus 12 is equal to 14, and then we obtain a is equal to 2. So a is equal to 2, that is the first term, and the common difference d is 4 over 3. So here we are talking about a term, the 10th term. So we use U10, and we use the formula for the nth term, that is a plus n minus 1 times d. This is when we are talking about a term, a specific term in the sequence. And we are also talking about the sum of the first n terms. And when we are talking about the sum, we use S7. We use the formula for sum. So here we use Sn is equal to n over 2 into 2a plus n minus 1 times d. We have a last example whereby we are going to use the rule I told you earlier, that is, the nth term can be obtained by taking the sum of the first n terms minus the sum of the first n minus 1 terms. So we are given that the sum of the first n terms, that is Sn of a particular arithmetic progression, is given by Sn is equal to 4n squared plus n. So we have Sn is equal to 4n squared plus n. We have an expression for Sn in terms of n. So we have to find the first term and the common difference. So we can use the sum of the first term, that is S1, and we can use S2. So S1 is equal to 4 times 1 plus 1, which is equal to 5. So S1 means the sum of the first term is 5. So the first term must be 5. And then if we have S2, so we know that the first term must be 5. This is A. S2, to obtain the sum of the first two terms, we have to take 4 times 2 to the square plus 2. We obtain 4 times 4, 16 plus 2, 18. So we know that the sum of the first two terms is 18. So first term is A. Sum, when we add the first term and the second term, we must obtain 18. Therefore, the second term must be 13. Because when we add these two first terms, we must obtain 18. So, the second term, we can see that it is S2, so nth term Sn. Here we are talking about the second term, so it is S2 minus n minus 1, S1. That is 18 minus 5, which is 13. So we can conclude that the first term is 5 and the common difference D is 13 minus 5, which is 8. This is part A. Now for part B, we have to find an expression for the nth term. Now for the nth term, we have A plus n minus 1 D. So we can write UN as 5 plus n minus 1 times 8. And we obtain an expression for the nth term. 8n minus 8, UN is equal to 5 minus 8 minus 3, 8n minus 3. So this is a general expression for the nth term. That's all for today. Thank you.